Okay, question B2 says this question is about projectile motion. Okay. A ball is projected horizontally at 5 meters per second from a vertical cliff of height 110 meters. Assume that air resistance is negligible and use g equals 10 meters per second squared. Okay. We have a height of 110 and we have a horizontal speed of 5. Alright, let's have a look. State the magnitude of the horizontal component of acceleration of the ball after it leaves the cliff. Okay, we need to then remember that the horizontally there are no forces acting, so horizontally the acceleration will be 0. Okay, it says acceleration there, there's no horizontal acceleration, so we just say 0 meters per second squared and get the mark. Okay, question 2. On the axes below, sketch graphs to show how the horizontal and vertical components of the velocity of the ball, Vx, and Vy, change with time t until just before the ball hits the ground. It's not necessary to calculate any values. The horizontal velocity, well, there's no horizontal acceleration, so it will just remain constant at 5 meters per second. I'm going to say that to the right, which is the direction it's going, is going to be positive, so it's going to be going like this. And this value here is 5, if that's meters per second. Although it did say that we don't need to write any values, and so you can get the marks without the values. Okay, and then the y velocity, well, we know that it's going to be accelerating downwards at 10 meters per second squared. So the y velocity it starts off at 0 because it's going horizontally, so it has no y velocity, so it's going to start off there. And it's going to accelerate at a rate of negative 10 meters per second squared. It's going to go like this. Because the velocity is going to get smaller and smaller at a steady rate. Sorry, it's going to get bigger and bigger, but negatively at a increasing rate. By the way, in this question, you got full marks if you did it with a positive gradient, because the decision whether you use negative or positive is kind of one that we make, and you can get the correct answer either way. Okay, B, calculate the time taken for the ball to reach the ground. Okay, so we had S equals 110 meters, and U, this is the time taken, so we're only dealing with vertical stuff here. So Uy is 0, and we know that A is negative 10 meters per second squared, which is what we were told. We were told not to use 9.81. And so now we need to use the appropriate equation, which is S equals ut plus half at squared. Okay, ut cancels because u is 0. So we get t, we can rearrange this equation. T is going to be equal to square root 2s over a. And that rearrangement is just, we multiply both sides by 2, we divide by a, and then we take the square root of both sides. And that's equal to the square root of 2 times 110 over 10, which is the square root of 22. So let's work out what that is. 22, where's my square root sign there? Which is 4.69. Okay, and we only have things to two significant figures, so that should be 4.7 seconds. Okay, calculate the horizontal distance traveled by the ball until just before it reaches the ground. Okay, now that we know the time that it's in the air, we can do this quite easily. So time is 4.7 seconds. The horizontal speed, we were told, was 5 meters per second. And so v is equal to the change in displacement over the change in time, which is 5 over 4.7. Oh, whoops, what am I doing? Let me just fix this. We're not doing that. So we're wanting to find S, how far it goes horizontally. So delta S is going to be equal to V delta T, which is 5 times 4.7, which is 5 times 4 is 20, 5 times 7 is 35, so 23.5. Okay, so question, we need the units as well. S is measured in meters, so that's meters. Another projectile is launched at an angle to the ground. In the absence of air resistance, it follows a parabolic path as shown below. Sketch the path that the projectile would follow if air resistance were not negligible. Okay, if air resistance is not negligible, the speed, there's going to be a force acting in the opposite direction of motion throughout the motion, which means that it's going to, from the very start, it's going to reach a lower height and a shorter distance. And because it's slowing down horizontally as well, it means that the whole thing is going to be asymmetrical, because initially it's going to have a high horizontal speed and it's going to end up with a lower horizontal speed. So the graph should look something like this. Okay, that's kind of exaggerated, the asymmetry, but there are 3 points that this question was looking for. That's the lower height, the shorter range, and the asymmetry of the graph. Okay, so that's the end of question number 2. We'll have a look at question number 3 in the next video.